Okay, we're still with properties of radicals, and we're going to look at the quotient property. The quotient property looks like this. The nth root of a over b, quotient, you know, means division, can be split up as the nth root of a over the nth root of b. Once I have them split up, I can go ahead and simplify them just like I did in my properties of my product property. So I can split them up just like that. Okay, well, let's look at an example of this. Here, this should be in yellow. Let's go ahead and highlight that. Looks like I need to sharpen my yellow pencil here. Okay. Good night, babe. All right, quotient property. Here's an example. The cube root of 81 over 8. So what I'm going to do is I'm going to split it up. I have cube root of 81 all over cube root of 8. Well, again, on the bottom one, I know that, that the cube root of 8 is 2, and most of you know that. The top one, though, not quite so sure about, so I'm going to go ahead and split it up. I know just right off the bat that 81 is 9 times 9. I'll keep this cube root of 8 going along with me. But I'm looking for 3 of something, and I only have 2 9s, so that's not going to help me. So I'm going to split up the 9 some more. So I'm going to split it as 3 times 3 times 3 times 3, right? There's my 2 9s. I have one of my 9s is 3 times 3. The other 9 is 3 times 3. And then I have my cube root of 8. Now I know you know cube root of 8 is 2, and I know that that 2 is going to be underneath. Here I need 3 of something to bring 1 out. So 1, 2, 3. That's going to bring out a 3 outside that radical sign. This one is going to remain. So my answer here is going to be, let's see if I can write it. Something is in my way of writing way over here. Is going to be, oops, I forgot my 3. Here's my 3 from the purple, cube root 3 all over 2. And that's going to be my answer. Sorry, I have something in the way of my hand right here. Okay, and that's my answer. So I have 3. Those are from my purple. Here, I can even make it purple if you want, if that will help. There's my purple 3. And here's my green 3 that had to stay behind because I didn't have any more to match them up. Okay, so they stay behind. Cube root of 8 is 2. Okay. That's what you do. Now, I told you that simplest radical form has another piece to it. And I think you probably remember this from geometry. But the other piece, the second piece, is that you have to rationalize the denominator. Okay, rationalize the denominator. And what rationalize the denominator means is, I think I was supposed to write it out here and I messed up. Rationalize denominator. And what it means simply is no radicals allowed in the denominator. Okay, no radicals allowed in the denominator. Well, that makes everything just a little more difficult for me because I can't leave anything as a radical in there. Okay, so I may have to do something about that. Well, let's see. Here's an example of what to do. Here's a simple example. We'll go into some things that maybe aren't quite so simple. All right, let's go with the, I wrote it big. 15 over the square root of 3. We'll start with something really simple. Okay, I can't have a radical in my denominator. We talked last time that 1 is this really great manipulation number. So we are going to manipulate this and simplify it by multiplying by 1, but it's going to be a special 1. A special 1. Let's see, how about blue? And I need 2 3's to take 1 out, right? I need 3 times 3 because this would be a 2 and we don't show it, but okay, I need 1 more. Well, what if I did this and I multiplied by this special 1, square root 3 over square root 3? What that would get me is this. I'm going to use that product property, 15 times square root of 3. This is outside the radical, this is under the radical sign, therefore they cannot be multiplied together. If you're outside, you have to stay out. Okay, if you're under the radical sign, you got to stay under the radical sign. You don't get to move around. So I can't multiply those two together, but I can do it like this. So what I have is 15 square root 3. On the bottom, what I'm going to end up with is square root 3 times 3, or I have 2 3's. I only need 2 to take 1 out. Or here's another way to look at it. Okay, just in case, that's square root 9. And you know the square root of 9 is, 3. So I have 15 square root 3 all over 3. Looks to me like I can reduce these. They can be reduced. So I'm going to go ahead and reduce. So 3 goes into itself once, into 15 5 times. And my actual answer then is going to be, again, something's in the way of my hand, 5 square root 3. And that's my answer. I use this 1 to rationalize. It's what we call rationalizing the denominator. I got to get rid of this. Okay, let me do one with a variable. So sometimes that helps straighten out some confusion here. So here's another example with a variable. Another example with a variable. Let's do this. I'm just going to put 2 over third root of x squared. Okay. 2 over the cube root of x squared. I have a radical in the denominator. I can't have that. I need to rationalize it. So I have 2 x's here, but I need 3 to be able to get rid of the radical sign, right? This is what tells me how many I need to get rid of. I mean, how many I need to get 1 out of the radical sign. Well, I need 3. I have 2. I only need 1 more. This is going to be cube. I only need 1 more, because then that would give me 3. What I'd end up with is, this is outside the radical sign. Under here, what I'm going to get is cube root x cubed, and the cube root of x cubed, of course, is x, and that's what comes out. Now, I can't reduce these two because he's outside the radical sign. This guy is under the radical sign. They cannot be reduced. Only time you can reduce is if they are both under the radical sign. Okay, so you always want to check for that first. So here's an example with a variable. Okay, let's do this. Let's look at this multiplication again and multiplying radicals. Because this is the other part of it that you need to know. So if I have something like this, and I want to multiply this together, I'm going to have to look at these kind of separately. But the first thing I'm going to do, so my step one, and here's some steps. Step one is to simplify the radicals. Okay, simplify radicals. So, and I know I can simplify this one, b5 square root, let's see, 4 times 6, right? 4 is a perfect square. I'm looking for a square root, right? It's a perfect square. So I can pull out from this a 2. That's going to give me, I would have 5 times 2 square root 6, or 10 square root 6. Over here, I know that what I have is 4 times 2. That 4, when I pull it out, is going to give me a 2, right? The square root of 4 is 2. What I have is 3 times 2 square root 2, or 6 square root 2. Okay, and I'm still multiplying these. When you multiply them together, what you're going to do is you're going to grab everything on the outside. So I have the 10 and the 6, and I'm going to multiply those two together. So I have 10 times 6, and under my radical sign, I have these two, the 6 and the 2, so 6 times 2. Here I'll have 60 square root, 6 times 2 is 12. And then, so what I have to do here is, okay, let's write some, I forgot to write my steps. Simplify the radicals is what I did. Multiply numbers outside together. Multiply numbers inside or under the radical sign. We'll say under together. And then see if you can simplify more once you bring it all together. Okay, so, and that's what I'm looking at right here, and I'm seeing this 12, and I'm thinking, you know, 12 is 4 times 3, so I have 60 square root 4 times 3. Well, 4, that's going to get me a 2, so I'm going to bring that out. I have 60 times 2 square root 3, or 120 square root 3, and that is actually going to be my answer. Okay, so when you're multiplying, you're going to simplify, and then once you simplify, you can multiply the numbers on the outside together. Okay, multiply the numbers under the radical sign together, and then see if you can simplify again. Let's try one. Let's try one with some letters. Let's see if I can find a nice one with some letters in it, some variables. Well, let's try this. Oh, you know what? Let's do this one. This one has to do with quotients, and I want to show you this too. If I have this, square root 27 over square root 3, what I want you to do is don't automatically start multiplying by that special 1. I want you to check first, and I'm going to put this in blue. Can you reduce at this point? And ask yourself that question. I'm going to even put it in red. Of course, if this is my orange because I didn't grab red, but there you go. Put that in red for yourself. Because 3, they're both under the radical sign. Okay, they're both under the radical sign, so 3 goes into 27 9 times. So what I'd have is square root 9. Well, what's the square root of 9? 3. and I have my answer really quickly. I didn't have to rationalize the denominator at all. Okay, I think that's good for these notes. We will work a lot with this in class, so I will let you go. You're all finished.